Alright, what's good, Stat 113 people? So today we are going to start our section 6 section of notes. And so this is a pretty big section on simple linear regression, so we will be spending a couple weeks on this note packet just to talk about ways that we could use a regression model in statistics. And so to just start out, we're just going to talk about how to explore data with two quantitative variables. And so if you remember, we've already talked about situations where we have a single categorical variable of interest, two categorical variables of interest, and a single quantitative variable of interest. So this is kind of like the last situation that we haven't really talked about yet. The data that we're going to use is a data set from our textbook. And so we have some data from UT Austin that we used in the last section that has course evaluation scores for different professors at the university, as well as the professor's physical attractiveness. And so that was rated by students that did not take the professor's class. They were kind of a separate panel of students that rated attractiveness of different professors. And so eventually our goal is going to be, or one goal at least that we're going to have, is we're going to want to know if there's statistical evidence for an association between a professor's course score and his or her attractiveness. And so to start, we're just going to look at, okay, well, I have this data, how would I just initially explore it? And the common graph to make in this situation is a scatter plot. And so we're going to put what we typically think of as our response variable, course score, on the y-axis, and what we typically think of our explanatory variable, in this case attractiveness, on the x-axis. Then on the plot, each point just represents a course. And so the point that I just circled, for example, would represent a course where the professor's attractiveness rating was about an 8, and he or she had a course score of about 3.3. And so each point is going to represent a different course at UT Austin. Putting all the points on the same graphic gives us our scatter plot. And so if we're describing the relationship between course score and attractiveness, the most common metric to describe that relationship is correlation. And so correlation in kind of common everyday language just kind of has the same meaning as association. But in statistics, correlation has, it's a specific number and it has a more precise definition. And so correlation we're going to typically denote as R, either capital or lowercase. And our definition is going to be, it's just a descriptor, so it just describes the strength of a linear relationship between two quantitative variables. This correlation, correlation coefficient is always going to be between -1 and 1, with values close to -1 indicates a strong negative relationship. Close to +1 indicates a strong positive relationship. And close to 0 indicates little correlation, or a weak relationship. And so we could use this first figure from our textbook to kind of talk a little bit more detail about what this stuff means. So what does negative mean? What does positive mean? Well, so positive is going to be like this first row. And so positive for a relationship just means that as x increases, so as x goes from small to large, y also tends to increase. Negative is going to be the reverse. And so we see in these three graphs that as x increases, y is going to tend to decrease. And then something that's close to 0, maybe this graph here. So as x increases, y tends to neither increase nor decrease. All right, and so we see in these two graphs on the very right, these two are perfect correlation. So the top right one is perfect positive correlation. The bottom right one is perfect negative correlation, meaning that if you drew a line through the points and you drew the line correctly, so remember I really can't draw even something as simple as a line. If you drew that line, then all of the points would fall exactly on that line. Okay, so let's jump back to our example. So we've got our scatter plot, and let's venture a guess for what the correlation is going to be for this example. So take a moment to just come up with a guess yourself. Okay, did you do it? Nothing like a fun, awkward pause in the middle of a YouTube video. So my guess was that I'm seeing like a very slight positive relationship. It almost looks similar to this graph in the bottom left. And so my guess is, I don't know, 0.07. So something small but positive, because we see that there's a very kind of weak relationship between course score and attractiveness. This is just a guess, so as long as you're in ballpark, so you're not saying like negative 0.5 or positive 0.7, we're kind of counting that as good. And so a correlation coefficient is only used to describe linear relationships. So it shouldn't be used to describe anything nonlinear. And so what's nonlinear? We'll talk a bit about that more a little bit later. But these three examples from our textbook all show nonlinear graphs. Because if you kind of drew a curve that kind of was best fit for the points, there's curvature. So these graphs can't be described by a straight line. We're really seeing this curved pattern, making them non-linear. So nonlinear, we're just thinking about as any scatter plot where there's curvature present. Okay, so just to kind of quickly sum up some of the stuff that we've talked about, so assessing correlation from a scatter plot. When we describe a scatter plot, we're going to look into talking about three things. We're going to talk about direction, so either positive or negative, where positive, remember, just has this increasing trend. Excuse me. Negative has this decreasing trend. We're going to talk about strength, and so we could describe the scatter plot as either strong, moderate, or weak. And so an example of strong might be something like that, where the points are going to be very tightly clustered around a fitted line. I should label my axes. It's bad. Bad. Okay. And so then moderate, I'll make this one positive. That's going to be Something where like you could tell there's a relationship, but the points just aren't as tightly clustered around the line as it is for a strong graph. Weak is more like something we see in our actual example. There could be like a slight trend, but the points really aren't that clustered around the line. So there's my example of a weak graph. And then finally, we could describe the trend as either linear or nonlinear. And so the only thing I want to mention here is that linear could mean, I think what most people think about as linear, as like something like this, where if you drew a line, there's no real curvature there. Or linear could also mean that there just isn't really a discernible pattern. So because a plot like this doesn't show curvature, we're still counting that as linear. Nonlinear is just like the examples above. I'll draw one more, so maybe this graph would count as nonlinear because there's clearly this curved pattern here. Okay, so in the handout, you'll get a little bit more practice guessing correlation from a scatter plot. And so since we're already over the 10-minute mark, which I'm trying not to do, we'll kind of leave it at that. As always, let me know if you have any questions.